Malware authors are getting a little too creative and it's kind of freaking me out. We're talking about a couple things we're seeing on GitHub today. In particular, it kind of starts with this weird obfuscation technique people are seeing where in packages uploaded to GitHub that are fed in as NPM packages and VS Code Marketplace packages, we're seeing this little pattern of code here where malware authors are hiding malicious JavaScript inside of this string. Literally, there could be thousands of characters in here, and they're obfuscating it by packing it in as this Unicode variation selector. So there's a bunch of different characters in the Unicode spec that actually don't render as anything. If you're to open a file like this in VS Code, or I think even Vim in some cases, this piece of code would not render as anything. I think even in a GitHub commit, you wouldn't see any code inside this block. And so this loader here literally just runs, it takes a string and it takes it and removes the Unicode like top end of the string and then runs it into an eval, and that runs the code arbitrarily, right? So it's basically giving them arbitrary code execution from a string that your browser or your visualizers, your text editors can't even render, which is crazy enough to begin with, right? But then I was reading this article and it hinted towards this other article that hints at the same threat actor. They're calling this Glassworm. And I think Ars Technica kind of missed the boat on what's actually going on here. The crazy part is how the C2 is working here. So you guys remember Shai-Hulud, right? Shai-Hulud was this bug that was infecting maintainers of NPM packages so that when they committed code to NPM, it would install like a Shai-Hulud backdoor into the package. People would download that package and it would self-replicate, right? There's another one coming down that is attacking the VS Code extension marketplace, and the way that it propagates is even worse, okay? So this is the company that has an engine for detecting this stuff. Obviously, if you want to see them, go check it out. Not a sponsor, just part of the video. So they're using kind of the same technique, and I want to highlight kind of the hilarity of this screenshot here. See this massive gap between lines 2 and 7? Yeah, dude, it's the size of the fucking Sahara Desert. If you don't see this, I don't know really what to tell you. You know, some text renderers may see this differently, but like when you look at this code, you're like, if you don't think something suspicious is going on here, I'm not really sure what to tell you. That being said, you know, maybe you don't read all the code in your packages. It's very common for people to not read all their code. Unfortunately, the nature of like the Python, Node, and OpenVSX like marketplace ecosystem is that you don't read like over half the code you use, which is like kind of terrifying. A lot of it is dependent on trust. You have to kind of just like look at the number of stars the packages has and hope that like the stars is indicative of trust, right? But in any case, they have these packages that are coming down with these payloads that are obfuscated via this Unicode technique, right? We're using Unicode characters that don't render as anything and then de-encrypting or de-encoding the Unicode to run the malware, right? But this is where it gets crazy. I don't know a ton about crypto. I do know that like Bitcoin has been crashing or something, but they use the Solana blockchain for C2. Like I didn't know you could communicate over crypto. I didn't realize you could like send messages. So what they do is inside of the payload that gets decoded, they are using attacker wallet strings to send and receive messages via Solana. So it's like, you know, they pay a market fee of less than a cent. And when they do this, they get data from the transaction that contains links to their C2, to their like payload upload server where they send all the encrypted data. Now, why is this brilliant and terrifying? I agree. First of all, the transaction is immutable, so you can't be deleted. Like it can't go away because the nature of a blockchain is literally that the blockchain is ever growing. It is globally distributed and is immutable. You can't change it. Also, yeah, by definition, there is no KYC. There is no know your customer on these wallets. So by design, the Solana transactions are anonymous, and then it's legitimate. Like this is part of the Solana blockchain. So if your network allows Solana transactions, which most of them do, no real way to get around this, okay? And yeah, it's very cheap. It costs them less than a cent, like fractions of a cent to execute this transaction, okay? So in that link, they contained their C2 payload, where they then told the C2, the malware on the other end, to encrypt the data with AES-256 CBC. Now, obviously, this is symmetric encryption, right? So if you were locally on that computer watching this occur, you could see the HTTP response headers, and you could see the 256 encryption key. Not super impressive there. But then, after all of this runs, they use a Google Calendar link to turn your computer into a proxy for this network, right? So they use a Google Calendar invite to download this zombie payload. I don't know what zombie stands for. I guess it's like a zombie botnet. And then they turn your computer into a proxy for their criminal infrastructure network. They literally are like, all right, cool. So we've downloaded all your stuff. We've done the transaction off the Solana network. And then they use all of this to turn you into a proxy SOC server so they can bounce in between your computer around the network. All the while, the Glassworm malware is using this to steal GitHub access tokens to push copies of itself into Python repositories, right? So we kind of talked about like the JavaScript side of this, using this loop, right, to like decode itself. Well, this same process of just doing an eval on data that you decode that can't render in a text editor can apply to Python too, right? The attack targets Python projects, including Django apps, machine learning research code, Streamlit downloads, and PyPy packages by appending obfuscated code to files like setup, main, and app. Anyone who runs pip install from a compromised repo or clones and executes the code will trigger the malware. What? The decrypted payload is executed entirely in memory and never written to disk via eval on Mac or Linux or in a VM script sandbox on other platforms. A persistence lock is written to init JSON with the current timestamp, and the malware will not re-execute within a 48-hour window on the same machine. Guys, this is like advanced malware, like C2 tactics kind of stuff. It's a little crazy, actually. So 2 packages in particular have been found: a React Native international phone number and React Native country select. The rogue versions detected on March 16th have been found to contain a pre-install hook that invokes obfuscated JavaScript to initiate a series of actions to skip Russian victims. Interesting. By inspecting environment variables and operating system time zone, and reaches out to a hard-coded Solana wallet, also linked to Glassworm, to extract the payload URL and deliver platform-specific malware. What could this possibly be? I don't know, man. So like, if you're in this world where you think you're, I guess if you're a developer of any language, maybe do a few things. First of all, check to see if you have this init JSON on your computer. Also, like, I think the recommendation from Ars Technica is you have to like inspect the packages before putting them in the projects. That's not happening. If you're seeing this weird, like, take this data and subtract in your code, I'm sure there are ways we can find this via signature. Also, if you're gonna be downloading packages from OpenVSX, if you see a non-authorized publisher and a repo that has like maybe like 4 or 5 stars, or like stars that are not proportional to the download amount, maybe don't install that. That being said, I think like downloads and ratings together is probably also not indicative of like trust, right? It probably is, I don't know, I've never done this before, I don't know, but it probably is easy to spoof a rating or to spoof download numbers. I'm not really sure, but in either case, just watch what you're downloading. Maybe you could audit the packages before you use them. It's not the easiest thing to do, but it is an easy way to make sure you don't get hacked. I don't know. So what do you do? I don't know. No, I'm just kidding. There are probably like 2 things you should do. One, have like active measures, right? Where you have maybe scripts set up where you're checking for patterns like this. I'm sure you can find signatures for these things online somewhere that are looking for self-decoding data that gets ran into an eval script. That is probably doable pretty easily by like a static analysis engine. And then also on like the more like dynamic, like higher level side, defense in depth, right? Make sure you have zero trust architecture in your networks. You're using multi-factor authentication so that if one thing gets compromised, it isn't the only thing that you need to upload malicious code to your GitHub, right? That being said, if you like this video, hit that like button and then go check out this other video that I think you will also enjoy just as much. We'll see you over there. Take care. Goodbye.